So welcome to a quick video on the OpenSourceEcology Open Source Battery Pack, which is at this page here. The idea is to create an 18 volt pack that contains 18650 cells, standard, off the shelf, easy to get hold of. No need to be when you order it, there's no need to have somebody sell you the open source design and for them to get a dangerous goods certificate. You can be responsible for buying the cells yourself. Right, so this is very much like a AA battery holder, except it has a space for a current limiter, etc, etc. However, and BMS, when you charge it, don't damage the cells and it balances them properly, etc. However, what we also wanted is for this to be usable not just for power drills, but also to be able to put them in parallel and series into larger packs to make much higher power provision and actually voltage and ampage provision. So here was the original concept drawing, which you can see it was up here. It was a flat pack, and some bus bars that could be connected at the side, which you can see just here. These yellow dash orange things. You can see the internal things of where there's some internal bus bars, and I found a thing where somebody used pour-on foam as a substitute for a spring, which is a really good idea. Martin and team found a very good little cheap and cheerful Chinese thing which you can get on BMS and current protector on AliExpress, which you can get for $2.53 with free shipping to the US. Woohoo! So here's from some of the quick screenshots as I've been doing the development, and a full description of the page. You can see all of that yourself online at that web page, wiki.opensourceecology.org/open_source_battery_pack. I'll put it in the Yaochub video later. I just want to go over the internals here. So this is the pack, and the idea is that if I put that view from there, that's the side on. The idea is that you can, where false, let me true. You can stack them in hexagonal offset arrangements, and at the so you'd have a fourth one here, so it goes from the right to the left to the right to the left, and what happens is that these the bus bars, these will capture the odd numbers at one end and keep them together, and at the other end the bus bars on the odd even numbers ones will capture the ones at that end. And because of the interlock, I don't know if you can see just in between the cells inside there, just in this gap here, you can see that cell. It's locked inside the green part of the case, another one, so the packs won't slide out sideways, because they're only held at one end on the odd things, and the other end on the even ones. They're not held at both ends on odd and at both ends on the even numbered stacked cells. If you don't want to do that and you want to stack them up one on top of the other, that's absolutely fine as well. It's just you'll lose a little bit of space because the bus bars thing, but you will end up with the bus bars all at one end. Now, the other thing is that you don't actually have to use the bus bars. You can. Let me remove remove my external bus bars. Here we go. If false, no, then don't do that. Inside here you can see in red there's the PCB. I've not yet finished this thing. Basically what you will be able to do is screw in to these things. There will be some metal with a screw holder terminal inside there, recessed. You will be able to screw in something that fits a piece of wire. So as a single pack you will be able to put something with Anderson plugs on it, or XT plugs, or whatever you want plugs on it. It's not going to be hard to do something like that. Now, one safety feature I've got on here is, can you see that this is the pack here? There's a step here, and the idea is that you would clip on an outer thing, so that for transporting these, they're below the PATA UN 3841 PATA 966 Schedule 2 limit of 100 watt hours per pack, because if you have 5 cells at 3035 milliamp hours times 5 times 3.6 volts, that actually comes out to about 60 watt hours. And if you are basically a laptop battery, if you're below 100 watt hours, you can take it on a plane. Clearly, obviously, if there is a open end on there where you can see the terminals and it could possibly short circuit, that would be bad. So the idea is to have a plastic cover that will fit on there around this part here at the end, which will cover up the terminals. You could even clip it on, screw it on, whatever. So that's for the safety. Now let's have a look inside as to how it's constructed, and for that we're going to take the lid off. Let's find lid. Where's lid? Lid. If true, false. Goodbye lid. There we go. So here you can see that the cells fit in to slots. They're loose. They are not soldered or spot welded in. I'll explain that in a bit. And if I take these cells out so you can't see those as well, if true on the cells, if false on there, take those out. Here you can see how you can insert the BMS circuit board with the current over voltage protection, blah blah blah, etc., into the thing. What I didn't want was to waste space, thing, but we wanted to go find just a quick off-the-shelf BMS circuit, and that one on AliExpress with the JW3317 is pretty good actually. 14 amp continuous max, 25 amp during charging. It's designed for rapid charging for what do they call, for drills. I mean, it destroys the cells, but that's not the supplier's problem. It's your problem, yay! But one of the things that tends to happen is that individual cells, particularly the first one and the last one, get destroyed by this process, and you have to undo all the tack welding, and it kind of gets a bit hair-raising. You can find all sorts of forums online about this. So the idea was to have slot in literally like a AA battery holder into the thing. Just pay attention. All of these are loose. These ends, they wobble about. But not when you've got the lid on, and the cells in as well. So in particular, the lid here clamps over that this end piece, the rounded end piece, to keep that from flopping about. And all of the other ones, they have not just screw holes. If you want to screw them in, and be a bit paranoid about it, put screws in every single one of those holes. But you can see here there is a slot was recessed, and if I get rid of the the thing and turn that round. Here you can see this part actually fits into a slot on the top there. That slots into there, which will stop them these support pieces for separating the batteries will stop that from flapping about, even if you don't put screws in absolutely every single hole. Okay, so strictly speaking, you only need to put the screws in this end and that end. Alright, that's to hold that on. I know it's a lot of screws, blah blah blah, etc, etc. We fixed, revision 1, etc, etc, get something done. Now, on the other end, I'm going to take that off. No, let's do this first. Now, for connecting the cells together, remember they're in series, so it's 3.6 times 5, which is 18 volt, which, funny enough, is pretty much the standard fare for all power tools. You'll see that there are these indentations, alright, here, and that is where you need to drop in a piece of nickel and copper plated steel as a bus bar and solder onto the back a 12 gauge wire which will cope the 25 amp load, which will sit in that circular recess, now semicircular recess behind the thing. Now they're separated, so it's fairly clear which ones you're connecting to the thing. So this one here is connected to that one. That one there is connected to that one, and you can see there's a channel for the cable between the two. And that one has to be connected to this one, which will contact with an otherwise dummy pressurized pour-on foam spring thing to give you the contact with the BMS wires thing. Now, on every single one, the reason for a big additional channel going right the way down through those things is because you need to run the terminal wire, the wires for to connect to the BMS, so to take the voltage levels, etc, etc. So those will be additional things coming through. So there's 1, 2, 3 will need to be on spring-loaded contacts onto the thing inside the inside the thing. So when you put the lid on, you just put the lid on and it contacts with the between the cells, but also gives you a point to read the voltage during charging, which is a critical part of looking after the cells. So that's that side. Now those are press fit. Those metal things, those metal pieces will be press fit into there, whereas on the other end they are backed by foam. Alright, so but I couldn't work out how to get the metal bus bars and the cables conveniently behind the channels for the thing. So what I decided to do was to have a separate piece that again is screwed into the back side of the thing, and on the end here you can see there's a little lip, because there's not enough room to this lip thing here, which fits into the main battery holder piece. But otherwise there's 1, 2, 3, 4, 5 screw thingamies which you can use to pressurize the pour-on foam thing. So the pour-on foam will go behind each of the bus bars, and in this case, unlike the other one where there's actually 6, because you're contacting one thing with the other one, on this end there will be a small one with a wire, a 25 gauge 12 gauge 25 amp wire that runs all the way along here to go in to connect to the BMS, to the back BMS with the current limiter, etc., etc. You can see there's plenty of room here. The metal will be in this portion here, and the pour-on foam will be in this portion here. So, and it will push the thing again up against the metal against the thing without damaging the batteries. Then the next one, because it goes up, that's the end, that will be the positive end, and it will go up to the double one. There's double ones here, so single right at the end to a double, which comes back down to a double, which goes back to a double, which goes and back down to a double here, whoops, and then up to a single, which happens to actually to be onto a contact, which happens to be the exact same design, which goes into the main battery case with the thing, and that's your negative. So it's negative 3.6 volt, 7.2, 10.8, 13 point something, and 18 volts there. Alright. So that's why you've got a single there, then a double, and then a double on there. But the odd thing is that the double, and then the double, which is actually a single. But yeah, you get the idea. The reason for the cutout there on the end here is because that's where the bus bar goes. It's a part cut out in the actual lid. If I put that back in, there's the other half of the cutout. Yeah. So it's important to note that only when the screws are in and it's covered, or the bus bars are inserted, or your cables are inserted with coverings, only when it's fully assembled is this thing actually safe. You short circuit things with these batteries. Some of the cells can easily do 25 amps. It'll arc, it'll damage your eyes, etc., etc. Start to heat up and catch fire. So until you've actually assembled it, pay attention, please. False. Okay, false. Let's take the lid off. So, the positive terminal cable will come dung 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 all the way at the back there, and come in on that end and connect to this end of the PCB. There will be there's some MOSFETs on the board. You can see them clearly if you have a look at the circuit diagram and the pictures. There's some MOSFETs on here which, in combination with a current limiter detection, will actually cut and isolate the batteries from the terminals at the end on the bus bars. So even if there is a problem, it's everything, but it's only when it's assembled is you get that protection. So the positive goes all the way down that end, and the negative comes from this last cell across that pseudo dummy twin bus bar that's actually a single one, and inside here, inside just at this location here, I will have another piece of pour-on back foam which pushes the a single square bus bar into the other end of that one, and there you've got your contact without having to worry about soldering when replacing the cells, or desoldering cells, or blah blah blah, etc., etc. So yeah, there's quite a lot of thoughts being put into this. Really appreciate some feedback, questions. Use the OpenSourceEcology wiki page discussion link to do that, or use the YouTube channel's comments. What was the other thing that we want to do? Oh, the reason for making this, well, apart from it being an angle, for later revisions, what we want to do is to actually design our own current limited circuit using either the JW3317 or preferably a circuit using the much better documented BQ Texas Instruments BQ76920, which the reason for wanting to use the BQ76920 is because it has an I2C interface for connection to an embedded controller plus full documentation of how the damn thing works. Consequently it's a much better thing, and we can start to put Bluetooth and 3G and Wi-Fi and LTE stuff in there, and have a internet connected thing. Alright, thank you very much.